from A to B. When you move from A to B, you're going in the direction of current. So the voltage drop across the 4 ohm. Fatma, will it be positive or negative, the voltage drop?
Negative. So can you
Negative.
repeat the question?
Yes, yes. The voltage drop across this 4 ohm resistor, if I'm moving from A to B.
It's negative.
It will be negative, minus 4i2. Then we can move to from B to C. When I move from B to C, then the voltage drop across this 2 ohm resistor, it's minus of 2 I2 plus I3 is equal to 0. So that's the voltage drop. So I can write this as that's minus I1 plus 10 minus 4I2 minus 2I2 minus 2I3 is equal to 0. Now see here, this minus 4I2 and this minus 2I2 will be minus 6I2. So I'm left with minus I1 plus 10.
So we are going along the direction of current.
Yes, if we are going in the direction of current, then the voltage drop is negative.
Yes,
If we are going in a direction opposite to that of current, then the voltage drop would be negative. It's my choice how I'm going to move in this coil. Also, we are just doing what we are doing is we are trying to add all the voltages. The sum of all the voltages in the closed loop is 0. So I'm just adding all 4 voltages in the loop. Okay. The sum of all voltages is 0.
Yes, sir.
That's Kirchoff voltage law. So minus 6I2 minus 2I3 is equal to 0 now. So that's my first equation. I need 2 more equations. For the next equation, let's start with this. We can move in this loop. Let's name this loop as C, A, D, C. Ahmed, try once. If you're moving from C to A, you're going in the direction of current or opposite to the direction of current? Ahmed.
Direction of current, it will
Direction of
be
current. It will be how?
minus
Very
1
good.
into I1
Perfect.
plus 10
Yes, lower to higher is rise plus 10. Very good.
minus
When,
4
when you're going from A to D?
minus 4 into I1 minus I2,
Perfect.
and then
If
it
you're
will
going
be
from D to C?
plus 2 I into I1 plus I2 minus I1.
I2 plus I3 minus I1, right, is equal
Yes.
to 0. So I can write this as minus I1 plus 10 minus 4I1 plus 4I2 plus 2I2 plus 2I3 minus 2I1 is equal to 0. So we can write this as this is I1, this is 4I1, and this is I1. So it will be minus I1 minus 4I1 is minus 5I1 minus 2I1 is minus 7I1 plus 10. 4I2 plus 2I2 is plus 6I2. Then we have plus 2I3, 0. That's second equation. Then we can take third loop. Third loop is this. So let's name this loop as this is CBDC. CBDC. So when I move from C to B, yes, Ahmed, what will be the sign of the voltage drop here? Positive or negative? I'm going from C to B, Ahmed. When I'm going from C to B, am I moving in the direction of current or opposite to the direction of current? Ahmed, from C to B, you're moving in the direction.
Yes, sir, we are moving opposite to the current, so it would be
Positive.
positive resistance.
So it will be 2 I2 plus
2 plus
I2 plus I3. Good. Next one. Then you are going from B to D. So this, the sign of EMF will be positive or negative?
It would be
Negative. You're moving from higher to lower. So higher to lower is false, negative, minus 5. Then you're going from D to C. Positive or negative? Positive. So that's plus 2. I2 plus I3 minus I1 is equal to 0. So if I multiply them, it's 2I2 plus 2I3 minus 5 plus 2i2 plus 2i3 minus 2i1 is equal to 0. So 2i2 is 4i2 plus 2i3 minus 5 minus 2i1 is equal to 0 now. That's third equation. Is it clear, everyone? Fatma, Mariam,
Yes, sir.
Abdullah? Abdullah have not written. So 4i2 plus 2i3 minus 5 minus 2i1 equal to 0. So we have three equations and three variables. Now, can you solve these three equations now?
Yes, sir.
So I'm leaving here. You can solve these three equations simultaneously. So you can solve 1, 2, and 3 and get the value of I1, I2, and I3. So I'm not doing this in class. Solve 1, 2, and 3. If you want to check whether your equations are correct or not, just Google, you will find various software which can solve these equations. You just have to put the values of I2, I3, and I1. That's it.
So can you say anyone?
Sorry?
Can you say anyone website?
I don't remember the name. Just type on Google software, online software to solve linear equations. That's it. You will get
Okay.
plenty of softwares. You don't need to download them. They're just website. Just put the values of the coefficient. They will give you the answer. So you can tally your results. Otherwise, it's just all example of NCRT. Even in NCRT, you can get the values of I2, I3, and I1. So that was about basic application of Kirchhoff law, in which you just calculate current through each resistor. In the next type of questions, we'll do some advanced problems on Kirchhoff law, where along with the current, you're supposed to calculate the voltage, the power dissipated, potential difference between any 2 points. Just note it down and tell me once you have it.
Yes, sir. Done.
Mariam, Fatma?
Yes, sir.
Done, sir.
This slide also?
Yes, sir.
So let's move on to the next slide. In the next slide, it's okay. Okay, Mariam. Is there any function or something today? Or vacations have started?
Vacations have started.
Vacation.
Okay, vacations have started. That's why half of the batch is missing. So your vacation is up to Sept, right?
Yes, sir.
Yes,
Yes,
sir.
sir.
So the next question is,
So in previous question, what exactly we have to find?
you're supposed to find the value of current through each resistor, I1, I2, and I3.
Okay, sir.
So I'm giving you this circuit.
So can you show the previous slide once again?
Yes, where were you?
Sir, I was here only.
No, you were not here.
Sir, I was here only.
Not here.
No, sir, not this one, the next one.
So yeah.
Yes, sir, done.
So okay. So let me find some question with previous years, some previous year question. Give me 1 second. Let me find one numerical from the previous years. So we can solve this numerical. This was in previous year. So it's 200 ohm. It's 20 ohm. It's 60 ohm. This is 5 volt. This is 4 volt. That's it. So let's call this point as P, this point as Q, this as R, this as S. So suppose to calculate first part, current through each resistor. Current through each resistor. After current, we will also calculate voltage across each resistor. We will also calculate voltage across each resistor. After voltage, we will also try to calculate heat dissipated across 20 ohm resistor. Heat dissipated across 20 ohm resistor. Then we will also calculate potential difference between any two random points like Q and S. We'll try to get the value of potential difference across Q and S. Let's say the internal resistance of this cell is 2 ohm. Fifth part. We also have to calculate terminal potential difference across 2 ohm resistor across this cell, the cell of 4 volt. This is the entire question. Like these all are the parameters that you may be asked to calculate here.
So what is that?
Q, S, and Ahmed. Q and S. Sorry. Point Q and point S. Okay, so tell me one thing. How will you start this question, Shazada? You're supposed to calculate current through each resistor. What will be the first step in this for solving this type of numericals? First step. Yes.
Sir,
We did Kirchoff law in the last class, huh?
yes, sir.
I'm just continuing that topic only. Yes, what's the
So-
first step?
First, we'll take like ESRQ like this. We'll start.
No. Before that, before taking loop, there's one more step left. Yes, Abdullah, what's the first step for solving these type of questions?
Sir, we divide the current.
Yeah, the first one is division of current. We'll take current in each resistor in each arm of the circuit. So we can start with any cell of your choice. In the last class, I have shown that if I take different types of division, the result would be same. Result does not depend upon the type of division that you are using. For this circuit, you can have many types of division. I'm choosing one of them. Like some current I1 is going out of this cell, the same current will enter it. Fatma, will there be any division of current when this current reach point P? When I1 reach point P? Is there any division?
Sir.
In how many parts this I1
Two.
will divide? 2 parts. Perfect. It will divide into 2 parts. Let's say some I2 goes here. What's the remaining current?
I1 minus I2.
I1 minus I2. Perfect. So is there any division of I1, further division of I1 minus I2 at Q? Fatma?
No.
No. Same current will pass here. Same will pass here. What happened at point R? Some I1 minus I2 is coming from Q. Some I2 is coming from this. So what will happen at this point? They will combine. So Ahmed, can you expect after combination what should be the current through this arm RS?
It should be just I1 because
be I1.
I2 and I2 will get cancelled.
Very good. So these two will add up to get I1. You can check from here also. I1 minus I2 plus I2 gets cancelled out. You will get I. You will get I1. So this is the last point, is the checkpoint basically. If on adding these two currents, you are not getting I1 because I1 should enter in the cell. Like on adding them, you are getting something like I1 plus I2. That means your division is wrong. The last point is the checkpoint. The current which goes out of the cell will enter the cell. It will divide into many parts throughout the circuit, but at the end, it will be I1. Is this division is clear?
Yes, sir.
Mariam, what are the number of variables in this equation? How many variables we have?
2.
Two variables. We'll make two equations. Let's start from this loop. Shazada, let's start from you. I'm choosing this loop. P, Q, R, P. Let's move from P to Q. How much is the voltage drop when I'm moving from P to Q?
So 5 volt.
Plus 5, minus 5.
6 plus.
Plus, if you're moving
Minus.
from high to low, it will be negative minus 5. Okay, Shazada, if I'm going from Q to R, then voltage drop will be positive or it will be negative? When you're moving from Q to R, voltage drop will be positive or it will be negative? Shazada.
It will be positive.
It will be positive. When you're going from Q to R, you're moving in the direction of current, right?
So it will be negative.
It will be negative. When you move in the direction of current, voltage is negative. It's minus of 200 I1 minus I2. When I'm going from R to P, Shazada, voltage drop will be positive or negative?
So R2P,
Yeah,
it will be positive.
it will be positive. Very good. You're going in a direction opposite to that of current. It's 20 I2 equal to 0. So let's add them up. It's minus 5. It's minus 200 I1 plus 200 I2 plus 20 I2 is equal to 0. So we have minus 5 minus 200 I1 plus 220 I2 is equal to 0. So we can take this minus 5 to the right hand side and we're left with it's 220 I2 minus 200 I1 is equal to 5.
Sir,
That is equation number 1. Yes.
sir, while writing these equations, will we consider the internal resistance?
Yes, we will consider internal resistance. We'll consider this internal resistance as a normal resistor.
Okay, sir.
Okay, let's take this particular loop. Let's take this loop PRSP. PRSP.
So,
Yes.
how do we choose the loop?
Clockwise or anti-clockwise?
Yeah.
You can choose anything. Like that's your choice. You can take clockwise or anti-clockwise as per your convenience.
The answer would be correct.
Answer would be same. Answer would be
The
same,
same.
exactly same. To get the same answer.
Mhm.
See, the only difference is if I'm choosing a, let's say, clockwise loop and I'm getting equation like x plus y equal to 0. Okay. On choosing an anti-clockwise loop, you will get minus x minus y equal to 0. Both are the same equations. There's no difference in between these two equations. So this is absolutely independent of the choice of the loop. You can choose loop of any, like clockwise, anti-clockwise, whatever you want to choose. Okay, so if I take PRSP, so when I'm going from P to R, I'm going in the direction of current. So voltage drop will be minus 20 I2. When I'm going from R to S, I'm again moving in the direction of the current. So this is minus 60 I1. It's minus 60 I1. When I'm going from S to P, I'm again moving in the direction of current. That's minus 2 I1. When I'm going from this negative to positive, it's plus 4. I'm going the rise in potential, it's plus 4. which is equal to 0. That's equation. If I solve it, it's minus 20I2. It's minus 62I1 plus 4 is equal to 0. That's equation. So this is first equation and this is second equation. So we have two equations and two simple variables. So if I solve this equation, what we can do is
So how did you get minus 200 I1?
minus 200 I1. This is 200, no?
Yeah.
I1 minus I2. So I multiplied it here.
I messed up while dividing the current.
Mm-hmm.
I took this one as I1, this one as I1, this one as I2, and this one I1 plus I2.
No, it won't be I1 plus I2. It will be I1 minus I2. Because if
No.
I1 is coming from here and I2 is going here, then you are left with I1 minus I2. No?
So this is positive charge, right? So it will
Right.
not take current. It will just give.
Sorry. What is it?
This side is positive, right? So it will just give like this.
See, Ahmed,
So the current goes from positive to negative, right?
No. Don't worry about that thing. That current goes from positive to negative. When we are doing division, the Kirchoff law, you can take current in any direction. The final answer will tell you that your division was correct or wrong. If your final answer comes out to be positive, that means your direction of current was correct. If your answer comes out to be negative, then it will imply that the direction of current is negative. That's the only thing.
Okay.
In this circuit, you can't you can't predict whether the direction of current would be this or it would be this, because you don't know whether this cell is charging or it's discharging. Right? Because if a cell discharge, then the direction of current is from positive to negative. But if the same cell charge, then the direction of current is from negative to positive. So we can't at all decide just by looking at the circuit that what will be the exact direction of current. So we assume the direction of current. The only thing that one should take care of is the division. That if some I1 is coming here, then it will divide into two parts. If one part is I2, then another will be I1 minus I2. Another cannot be I1 plus I2. If you take this as I2, let's say you're saying that this is I2. If you take this as I2, in this direction, if you take I2, and you say here it's I1 plus I2, then you are doing your division is
No, sir. I took this.
it opposite direction, right?
This direction, yeah.
Yeah. Then you can write this as I1 plus I2.
So we'll get the same answer if we do
You'll
this.
get the same answer, right?
Okay.
Say the value of I1 and I2 will change, but the current through this 200 ohm resistor would be same. When I'm doing this calculation, the current through 200 ohm resistor is I1 minus I2. But when you will solve it, your current through 200 ohm resistor would be I2 only, right?
Yes, sir.
So my I1 minus I2 and your I2 will match. The current through every resistor would be same. So answer will not depend upon what type of division are you taking. Anyways, now let's solve this equation. Let's solve this equation now, these two equations. So this is it. And the second one is it's 220 I2. Let's solve 1 and 2. So it's 220 I2 minus 200 I1 is equal to 5. Then we take minus 20 I2 minus 62 I1 is equal to minus 4. What should I do? If I multiply this whole equation with 11, so I will get, if I multiply it by 11, I will get minus 220 I2 minus 62 into 11. How much is 62 into 11? 62 into 11.
682.
682. 682 I1, which is equal to minus of 44. Now I can solve these two equations. When I add these two equations, I will get, see this 220 I2 will cancel this 220 I2. I will be left with only minus 200 I1 and minus 682 I1. So that will be minus of 882 I1, which is equal to, it's 5 and minus 44. So that's minus of 39 now. 44 and 5, right? Minus 39. So you can write that your I1 is, it's 39 divided by 882 ampere. Is it clear, everyone?
Yes, sir.
Next we can substitute I1 equal to 39 by 882 ampere in equation number 1. If I do these substitutions, I will get this is 220 I2 minus 200 I1. So it's 200 into 39 by 882 is equal to 5. I'm converting this in decimals. Huh? Let's convert this in decimal. That will save some time. So it will be, first of all, this is 39 divided by 882. So that's 0.044. So this is equal to 0.044 ampere. Next, it will be 220 I2 minus, it's multiplied by 200. So it's minus 8.8 is equal to 5. So we are left with 220 I2. It's 8.8 plus 5. 8.8 plus 5 is 13 point.
Yes, sir. 13.8.
13.8. So we get I2 is 13.8 divided by 220. So we get that I2 is
0.06.
13.8 by 220. 13.8 divided by 220. 0.062. Now that's I2. So this is I2 and this is the value of I1. So that's the first part of the question. You get the value of current through each resistor. Yes, Abdullah, you are right. Just note it down. Then we will see how to calculate voltage, heat, potential difference, and terminal potential difference.
So I got different answer.
You got difference, but when you calculate the current through this 20 ohm or 200 ohm or this 2 ohm, your mind I1 should be same.
I1 is same, sir.
I1 is same. The other things will remain same when you calculate current through 200 ohm. For current through 200 ohm, you're getting some answer. But for me, the current through 200 ohm is I1 minus I2. When I would solve I1 minus I2, my and your answer will match. Okay, Abdullah. Okay, it's namaz time. Let's have a break of 5 to 7 minutes. Then we'll continue.
Okay, sir.
Okay, so shall I start? Abdullah, shall I start now? Okay, so that was the value of I1 and I2. Fatma, Mariam, now just try to get the value of current through each resistor. Get the value of current through 2 ohm resistor, 200 ohm resistor. Get the value of current through this 20 ohm resistor. Calculate. You know I1 and I2. I think after calculating I1 and I2, it's a very easy calculation. Yes, Abdullah, minus will also come. Yes.
So current through 60 ohm and 20 ohm.
Yeah, not 200 ohm and 60 ohm. 200 ohm and 20 ohm. Two hundred ohm and 20 ohm. So in the first part, you need current through each and every resistor. So get the value of current through 200 ohm resistor. So for current through 200 ohm resistor. So current through 200 ohm resistor is I1 minus I2. And see how much is I1?
So we are doing this again.
Now we are calculating current through each one. Then we will calculate voltage.
Okay, sir.
So it's I1 is 0.044 and I2 is 0.062. So the current is 0.044 minus 0.062. 0.062. So when I subtract them, it's 0.044 minus 0.062. So that's minus of 0.0 0.018. Fatma, what is the significance of this negative sign?
Direction.
Direction, yes. So the current direction of current, the actual direction of current through this 200 ohm resistor is the reverse of the one we have assumed. We are assuming that current through this 200 ohm resistor is going to the right hand side, but the actual direction is reverse. So this negative sign simply tells that actual direction of reverse, actual direction of current is reverse. Next, we need current through 220 ohm resistor. Current through 20 ohm resistor, that is equal to I2, which is equal to I2 is 0.062. So Ahmed, your calculation and my calculation, through both the calculation, current through 100 ohm resistor will be 0.018. For you, it's directly I2 is current through 200 ohm resistor, which is coming out to be 0.018.
Yes, sir. It's all correct now.
So that will be same. Okay. Now we have current through each resistor. We know that current through 60 ohm resistor is current through 60 ohm is I1, which is 0.044 ampere. So we have current through each and every resistor. That's the first part of the question. The second part is you're supposed to calculate voltage drop across resistor. So if you have current, you can easily calculate voltage drop, right? The voltage drop across 200 ohm resistor. Voltage across 200 ohm. It's current into voltage. How much is current which is passing through 200 ohm? That's I1 minus I2 multiplied by 200. How much is I1 minus I2? That's 0.018. There is no significance of putting negative sign here. 0.018 into 200 volt. Similarly, you can get the value of voltage drop across each resistor. Voltage drop across, if you want to get voltage drop across 20 ohm, then that will be I2 into 20. How much is I2? That's 0.062. Mariam, is it clear? Voltage across each resistor now?
Yes,
No.
sir.
After calculating voltage across each resistor, the next task is to calculate heat dissipated across each resistor. Fatma, how do you calculate heat dissipated across each resistor? Yes, Fatma. How will you calculate heat dissipated across each resistor? Do you remember any expression for calculating heat?
Potential energy.
No, no. Abdullah, do you remember any relation to calculate heat dissipated across a particular resistor?
Sir, in initial minus
term-
final energy,
In terms of current,
in
any
terms,
formula?
sir, initial power minus final power.
Nah. Heat dissipated means power dissipated, nothing else. Heat dissipated means power dissipated. Abdullah, now, do you remember any formula for power dissipated?
Sir, power is equal to I square R.
I square R, right. So if I want to calculate power through this 200 ohm resistors, the current through this 200 ohm is I1 minus 8. So we can write this as I1 minus I2 square multiplied by R, which is 200. And how much is I1 minus I2? That I1 minus I2 is 0.018. 0.018 square into 200. So if you know current, you can calculate all quantities. Is it clear, Fatma? Heat dissipated?
Yeah.
Okay, after heat dissipated, the next part is to calculate potential difference between 2 points. Say you are supposed to calculate potential difference between Q and S. So to calculate potential difference, what we can do is start from Q and travel up to S through any path. What different paths you can choose? You can either travel from Q to P and then P to S, or you can travel from Q to R and R to S, or what you can do is you first go to P, then you go to R, and then you come to S. It's your choice. You can choose any path, but your potential difference will remain same. It will not change. And this is also a method to check your calculations. If your potential difference is not changing on changing path, that means you're going in the right direction. Your currents are correct. But if your potential difference change for different paths, that means you are going in the wrong direction. The value of current that you are getting is not correct, it's incorrect. So to get the potential difference, I'm choosing this path from Q, P, S, I'm going. I will go from Q to P and then P to S. When I'm starting from Q, let's put the potential of Q as some, let's say this is VQ. When I'm going from P to Q, see, I'm moving from lower to higher terminal of the cell. That means this is rise in potential. We take the rise as positive. So we write this as +5. When we move from P to S, this is cell of 4 volt. I'm going from high terminal to lower terminal. That's fall in potential. So I'll take this as negative, -4. Next, when I'm going through this one, right? I'm going in a direction opposite to that of current. This is the direction of current. Current is going to the left. I'm going to the right. So it will be 2I1 plus 2I1. Then when we reach the last point S, I call its potential as minuses. I'm using minuses because I'm supposed to calculate VQ minus VS. I'm supposed to calculate the potential difference between VQ and VS. So you can write that your VQ minus VS is, see, 5 minus 4 is 1. If you take this one to the left hand side, it will be -1. 2I1 to the left hand side is minus of 2I1. So VQ minus VS is minus of 1 minus of 2I1. How much is I1? I1 is 0.044. 0.044. So we are left with VQ minus VS is -1 minus 0.088. So I can write VQ minus VS is minus of 1.088 volt. So this is how we calculate VQ minus V1. Potential difference VQ minus VS is minus 1.088 volt. Is it clear, everyone?
Sir, can I again explain this QPS? Like the minus VS and VQ.
Okay. See, I'm going from Q to S. And the question it's given, I'm supposed to calculate potential difference between Q and S. Potential difference between Q and S means VQ minus Vs. So I'll be starting from this point. The potential of this point is some VQ. I name it as VQ. Then I travel from Q to P. When I travel from Q to P, I'm adding all voltages according to the sign convention, usual sign convention, Abdullah. But when I reach this point S, since I'm supposed to calculate the potential difference between Q and S, that's why I'm taking the potential of Q as VQ and that of S as minus of Vs. So that's why I'm taking this as minus of Vs. Yes, Abdullah.
Yes, sir, got it.
Do one thing. Choose any other path, like choose this path, QRS. Choose this path, QRS, and get the value of VQ minus Vs. What answer you are getting? Just write your answer in chat. I need answer of each one of you. Choose this path, QRS, move from Q to S, and write the value of voltage VQ minus Vs that you are getting.
So we don't have any potential like cell between QRS.
No issue. If you don't have cell, just take this resistor. Na? You need voltages.
Okay, sir.
Answers.
Sure.
Yes, what answer are you getting, Ahmed?
Sir, calculator. So the answer is in minus 1.02.
1.02. You're getting a different answer.
Yeah.
Okay.
And so I used my calculation for this.
Just check your calculations once more. This answer should not change. Fatma, what answer are you getting? You're getting nothing, huh? Mariam, are you getting anything?
No, sir.
No, sir. Abdullah?
And I'm getting minus 0.96.
You're getting a different answer. Okay,
Yes, sir. I'm checking, sir.
let's check it again. Okay, let's start from Q and travel to R. So when I move from Q to R, Mariam, start telling me. When I start from Q, what will be the first potential? Yes, Mariam. Start from this point Q. What's the potential of point Q? Write this as VQ. Now, Mariam, what will be the potential of here? 200 ohm resistor. It will be positive or negative if you're going from Q to R.
So it will be negative.
It will be negative, right? So it will be minus 200 I1 minus I2. So, Mariam, what will be the next potential that you will add or subtract? What will be the next potential? We travel from Q to R, then I'm traveling from R to S. What will be the next potential difference?
Minus 60.
Then current is I1.
Yeah.
Minus 60 I1. See, this is the last point S. You just have to travel from Q to S. For this last point, put it minus Vs. Is it clear?
Yes.
Now, start substituting the values. How much is I1 minus I2? That we have already calculated. It's VQ minus 200. How much is I1 minus I2? That I1 minus I2 is minus 0.018. Minus 0.018. Minus 60 I1. How much is I1? I1 is this 0.04. Minus V is equal to 0. Repeat this, just complete these calculations and tell me how much is VQ minus Vs now. I need answer of each one of you in the chat room. Just complete this calculation and write how much is VQ minus Vs now. Are you getting the same answer or not? Complete your calculations. So these are the extreme type of questions then one can get in Kirchoff.
So I got the same answer,
You got the
but
same answer.
in negative.
VQ minus Vs is negative.
I got it in negative, like minus 1.02.
So I'm also getting minus. Huh? So that minus sign simply means that VQ is at lower potential, V is at higher potential. That's it. Abdullah, are you getting any answer?
Sir, 0.96 only I'm getting. Both the
You're
time.
getting both the time. You take minus sign there?
Yes, sir, I'm taking minus sign also. I don't know what's happening.
Okay. Let others try then. Huh? Shazada, getting something?
Yes, sir.
I
Same.
say it's actually 0.96.
0.96.
Yeah.
Let me check now. You're doing it in the right direction. Now. VQ minus Vs. So it's 1 plus 2I1. So it's minus 1. Minus 2I1. Minus 1 minus 2. So it's minus 0.088 minus 1. Okay, let's try it now. So that's VQ minus 200 into 0.018. So it's 0.018 multiplied by 200.
Sir, plus 3.6.
3.6. 60 into 0.044.
2.64.
60 into 0.044. 2.64. That's negative. So VQ minus VS is so minus 3.6 plus 2.64. Okay, the very small difference. I'll tell you why I'm getting this. You are getting that small difference. 3.6 minus 2.64. It's 0.96. This is what you are getting, na? VQ minus VS is minus of 0.96.
Yes, sir.
See, this small difference in this and this is due to the fact that while subtracting these two terms, I've taken some approximations. This was not exactly 0.044. This was not exactly 0.062. So while adding and subtracting them, I'm taking some approximations. Due to those approximations, the answers are different. A very, very small difference here. If I have not taken those approximations, if I have calculated them in fractions only, then you will be getting the exactly same result. So this small difference of 0.04 something, it's due to the approximation that I'm taking while subtracting and while converting them from fraction to decimal. That's why. Otherwise, you would have get the same answer. Clear, Abdullah?
Yes, sir.
If you don't convert this in decimal, you take exact fractions, then both VQ minus VS from both the paths will lead to same value, exactly same value. Fatma and Mariam, is it clear now?
Yes, sir.
So these are the extreme type of questions in Kirchoff law. One last type of question is, like you may be asked to calculate terminal potential difference. Fatma, can you tell me whether this cell is charging or discharging just by looking at the direction of the current?
Charging? No, discharging.
Discharge. The direction of current is from positive to negative terminal. If current is from positive to negative terminal, then cell discharge. If the direction of current is negative to positive, then it will charge. The cell is discharging. So when a cell discharge, then how you calculate terminal potential difference, Shahzada, if the cell is discharging?
Dot product.
Sorry. If a cell is discharging, then how you calculate terminal potential difference?
IR.
No,
Is it?
not IR, not IR. In terms of EMF, we have written something. Check your calculations. We have done terminal potential difference for a cell which is discharging. Mariam, do you remember any relation for terminal potential difference if a cell discharge?
No,
No.
sir.
Abdullah,
Sir, E minus IR.
E minus I. So if you're taking this cell, E, then the current passing through this cell is I1. So we'll take I1, V minus I1R. Just substitute its values. So its E is 4 volt minus 4 volt. I1 is 0.044. 0.044 multiplied by internal resistance, which is 2 ohm, I think. Yeah, it's 2 ohm. So terminal potential difference will be 4 minus 0.088. So that 4 minus 0.088 comes out to be 4 minus 0.088, 3.91. That comes out to be 3.912 volt now. So if a cell discharge, then the terminal potential difference is E minus IR. If the direction of current is negative to positive, that means cell is charging. If a cell charge, then it will be E plus IR. That's for a discharging cell, E minus IR. So this is about Kirchoff law. These are the type of questions that one can get on Kirchoff law. There's one more type of question in NCERT that we will discuss. But first of all, note it down. See, Kirchoff law is a bit complicated, lengthy, but a very important topic. In boards, there's very strong probability of getting at least one 3-marker question from Kirchoff. Just tell me once you have written. Can I change the slide now?
Yes, sir.
Okay. Yes, can I change the slide? Shahzada.
Yes, sir.
Next, we have one derivation for balancing condition of Wheatstone bridge. We have discussed Wheatstone bridge and capacitors. Just note it down. Then we'll start Wheatstone bridge.
So done.
So Shahzada, what was Wheatstone bridge? We have discussed this in series and parallel combination. Yes, Shahzada, do you remember what's Wheatstone bridge? No,
So I was not there in the class.
you were not there in the class. Okay. Fatma, do you remember what's Wheatstone bridge? No. Okay. Mariam, do you remember what's Wheatstone bridge?
It can be solved using parallel or series combination.
It can't be solved. And what's Wheatstone bridge? It's combination of 5 resistors, which cannot be solved by usual series and parallel combination methods. So this particular combination of 5 resistors or 5 capacitors is Wheatstone bridge. This is R1. We have already discussed numericals on Wheatstone bridge, but we have not derived balancing conditions. So we'll derive balancing condition. 3R4. This is known as Wheatstone bridge. No resistor in series, no resistor in parallel. This is point A, this is point B, this is C, and this is D. That's Wheatstone bridge. So do you remember what is balance? What do you mean by balancing condition at Wheatstone bridge?
Yes, sir. R1, R1 and R2, like R1, R2 and R3, R4 ratio should be same.
Perfect. So balancing condition of a Wheatstone bridge means, if I'm saying that a Wheatstone bridge is balanced, that means no current is passing through this arm, balanced. And if no current is passing through this arm, then R1 by R2 should be equal to R3 by R4. This is the balancing condition that we are supposed to derive. So very simple derivation. Let's start from this cell. Some current I is coming from this cell. So Mariam, is there any division of current over point A? Will current divide at A?
Yes, sir.
Okay, let's assume some current I1 goes here. Then what's the remaining current here? Which will pass through R3. How much current will pass through R3 now?
I minus I1.
I minus I1. Good. Is there any probability of further division of current at B? Yes, Fatma. Is there any probability of further division of current at B? Shahzada, will current divided be?
Yes, sir.
So if I take this to be Ig, then what current is passing through R? If I take this current to Ig, how much current will pass through R? Yes, Shahzada. I1 is coming here. Out of I1, some Ig is passing through the galvanometer. How much current is left now?
The IG minus I1.
I1 minus Ig, right?
Yes, sir.
Okay. So here some Ig is going. Some I minus I1 is coming from this resistor. They will combine and some current I minus I1 plus Ig will pass through R4. This is current I which goes out of the cell. The same current will enter in the cell. Exactly same current will enter the cell. Now, to prove this balancing condition, we can start from this loop ABDV, ABDA. ABDA. Let's write the equation of this loop. Fatma, start telling the equation of this loop. I'm starting from A. Start telling the equation of the loop. Fatma, how much is the voltage drop across R1? Fatma, fast. Write the equation for this loop ABDA. Mariam.
Yes.
Yes. Start telling the equation of the loop ABDA. It's travel from A to B. How much is the voltage drop?
Minus R1
Hmm.
bracket I1.
Good. Then move from B to D. The resistance of galvanometer is G. This G is the resistance. What's the voltage drop across here? G is resistance. Consider G as resistance.
Minus
Hmm.
G.
IG into G.
Yes, I think it.
Then what about B to A?
Plus
Hmm.
I minus I1 R3.
Hmm. R3 is equal to 0. That's my first equation. So if bridge is balanced, Abdullah, which current will reduce to 0?
Sir, the minus IG.
IG will reduce to 0. Bridge is balanced means B and D points are at same potential. B and D are at same potential. That means no current will pass through IG. So IG will be 0. So if I put IG equal to 0 here, I will get minus I1 R1 minus 0 plus. So I'm putting IG equal to 0 here. I minus I1 into R3 is equal to 0. So you can write this as I minus I1 into R3 is equal to I1 minus I1 R. That's first equation. Is it clear? Fatma? Shahzada?
Yes, sir.
Bridge is balanced. That simply means IG is 0. No current is passing through this fifth resistor. Okay, now let's choose another loop. Let's choose this loop BCDB. Fatma, is your mic working now? Fatma. Okay, Shahzada, just tell me the equation of this loop BCDB. Let's start from B and do it faster. Shahzada, what will the equation of this loop BCDB?
Yes, sir. So it will be
Hmm.
minus
Hmm.
minus I1 minus I2.
So it will be minus of I1 minus IG multiplied by R2, right?
Yes, sir.
Then you're going from C to D. You're going in a direction opposite to that of the current. So it will be minus I minus I1 plus IG into R4. So minus I minus IG I1 plus IG into R4. I minus I1 plus IG into R4. Then you can move from D to B. When you move from D to B, this will be G into IG. Plus IG into G is equal to 0. It's okay.
Sir, it will be plus, right?
Which one?
Like
Yeah, it will be plus, right?
BCDB.
Now again, if bridge is balanced, IG equal to 0. When you put IG equal to 0 here, this is minus of I1 minus 0 into R2 plus I minus I1 plus 0 into R4 plus 0 is equal to 0. I minus I1 into R4 is equal to I1 R2. So this is equation number 1 and this is equation number 2. You can get the ratio of 1 into. Divide 1 into. So that's I minus I1 into R3 is equal to I1R. Then this is I minus I1 into R4 divided by I1 R2. So I1 will cancel I1, I minus I1 will cancel I minus I1. And you are left with just R3 by R4 is R1 by R2. So that's the balancing condition. This is how we derive balancing condition of Wheatstone Bridge. This is the balancing condition. Note it down. Now, one last numerical on Wheatstone Bridge. Okay. Yes, Shazada, Mariam, can I change the slide?
Yes, sir.
Sir, done.
It's okay. Okay, so that was a simple derivation of Wheatstone Bridge, balancing condition of Wheatstone Bridge. I'm not doing any numerical on this thing because we already discussed numericals on balancing condition of Wheatstone Bridge. The next thing is using Kirchoff law, you can also calculate equivalent resistance. See, Kirchoff law, if you look at these numericals of Kirchoff law very carefully, then through Kirchoff law, the first step is to calculate current. Once you have current, then through that current, you can calculate almost everything in your circuit, everything in your circuit, if you know current in the circuit. So the last application of Kirchoff law is using Kirchoff law. There are few examples, solved examples in CRT, where you're supposed to calculate equivalent resistance of a circuit. So see how we calculate equivalent resistance of the circuit using Kirchoff. First, understand the concept. It's not a straight away calculation, it's an indirect calculation. R equivalent using Kirchoff. To calculate R equivalent, first step is to get the value of total current. Calculate total current through cell. So if you have a cell in a circuit, get the value of total current through the cell. You can write total current as total EMF divided by R equivalent. If you remember your circuit series and parallel combination of resistors, then we have written there total current is total voltage by total resistance. Total voltage is the EMF of the cell. So in numericals of Kirchoff law, you know how much is EMF. Through Kirchoff law, you can get the value of total current. So if you know these two terms, then you can write your R equivalent is, this is E divided by I. So to get the value of R equivalent, this E is given in numerical. You always have the value of EMF. This is what you will calculate using Kirchoff law. And once you have I, get the ratio of E and I, and you can get R equivalent. So through this simple method, you can calculate R equivalent on some really very complex circuits. Like you can solve those circuits also which are not solvable by usual series and parallel combination. Note it down. We'll do some examples of these type of circuits. I'm writing one example. Remember, we will not calculate R equivalent directly, but we will first calculate total current. Then using that total current, we'll be calculating R equivalent. The circuit is. So can I change the slide?
Yes, sir.
There is one very interesting circuit in NCRT. So the circuit is this circuit. So each resistor have 1 ohm resistance. So each resistor have 1 ohm resistance. Each resistor, I should write it here. Each resistor have 1 ohm resistance. Each and every resistor have 1 ohm resistance. Calculate R equivalent across the diagonals of Q. So to get the value of R equivalent, what we can do is, see, these are the two diametrical points. Let's name this cube as something. Let's name it as A, B, C, D, E, F, G, H. So we have two diametrically opposite elements. One is B, another is H. These are two diametrically opposite points. So it's supposed to calculate the equivalent resistance across either across B and H or across A and G, across any two diametrically opposite points. See, you can't even think of solving this circuit using series and parallel combination. You will not get any resistor in series or in parallel. Each resistor is 1 ohm. So let's just connect this to a cell. See, cell is not given. The points across which you are supposed to calculate equivalent resistance, connect an virtual cell across that point. Let's say the EMF of the cell is I. Some current I is going through the cell. Somehow you have to calculate the value of I. If you can calculate the value of I, then the ratio of E and I will give you equivalent resistance. Now, over, let's say this is point H. So Fatma, if current reach at point H, then in how many parts this current will get divided? Current I reach point H, then in how many parts this I will divide? Mariam?
Yes, sir.
Yes, if some current I arrive at this point H, then in how many parts this I will divide?
3.
3. See, all 3 parts are identical. Mariam, all have same resistance.
Yes, sir.
So that means your current will divide into 3 equal parts. So how much current will pass through this 1 ohm resistor? Yes, Mariam. I current. I. Not I. See, I is coming and dividing into 3 parts. Divide no. I divide I into 3 equal parts.
I by 3.
I by 3. So this will be I by 3. This will be I by 3. And current through this resistance is also I by 3. So this current divides into 3 parts. One is I by 3. Sorry, not I3, it's I by 3. I by 3. This is also I by 3. So Abdullah, when this I by 3 reach at point E, what happened with this current? This I by 3 reach at point E. What happened with this current now?
It will again get divided into two more parts.
2 more parts. Both the parts would be equal.
Yes, sir.
So if divide I by 3 into 2 equal parts, then what each part would be?
I by 6, I by 6.
I by 6, I by 6, right? I by 3 is coming here, it will divide into 2 equal parts. So this will be I by 6. And this will also be I by 6. Similarly here, I3 is coming here, it will also divide into 2 equal parts. One is I by 6, another is I by 6 again. Similarly, when I by 3 is coming here, it will divide into 2 equal parts. One is I by 6, another is I by 6 here. Okay, Shahzada. Now let's consider this point A. Check very carefully, Shahzada. What currents are entering point A?
So I by 6.
How many
I
I by 6 are entering at A? 1 I by 6, 2 I by 6, 3 I by 6. How many I by 6 are entering? Yes. Anji.
Dramatically, all are there. All are coming there.
At point A, all are coming. I don't see all currents coming.
Here, 3 are coming.
2 are coming. See, one
Oh,
is coming from each
Yeah, yeah,
way.
yeah. I by 6 is not there. 2
2
are
are
coming.
coming. So I by 6 plus I by 6. How much is I by 6 and I by 6?
2 I by
2 I by 6, which is I by 3, right? So I by 3 is going here. Shazada, also check this point C. What's happening at C? How many I by 6 are entering at 6?
so 2.
2. I by 6 and I by 6 will enter. That means I by 6 plus I by 6, which is I by 3 will be. And what's happening at F? Same thing.
Sir, at F.
How
Yeah,
many
sir.
currents are entering at F? Same. 2 I by 6 are entering.
Yes, sir.
It will be I by 6 plus I by 6, which is I by 3. Will go here.
Yes, sir.
Now, Ahmed, just check point B.
So it
What?
will be I.
It will be I. See, 3 I by 3 are coming. One I by 3 is coming from A, another is coming from F I by 3, another is coming from C I by 3. So 3 I by 3 is coming here. So it will be I by 3 plus I by 3 plus I by 3. This is I. So I is big. So you can check. See, some I current is going out of the cell and the same current is going inside the cell. The same current, the same I current is going out of the cell and the same current is going into the cell. The same thing. Okay, now. So, can you count the number of variables now, Fatma? Just count the number of variables in the entire circuit. Fatma, you can answer in chat room if mic is not working. Huh? Just count the number of variables. How many variables we have in the circuit? Because now we have to make equations. For every variable, I need one equation. 2. And what are they, Fatma? What are those 2 variables? Ahmed, just check carefully. Fatma, it's one variable. Huh? There's one variable. There's one variable I. Now, I and I by 3 are the same thing. Like if I'm saying X is a variable, either I write it as X by 3, X by 6 is the same thing. I have just one variable in my equation. That's the beauty of this question. You have several divisions of current, but you have one variable, that's I. Right, Ahmed? You don't have 12 variables, you just have one variable. So for one variable, you need one equation. So for one equation, we can choose a loop. See, for calculating R equivalent, always choose the loop having the cell. Always choose the loop having the cell. choose this loop. So what's the name of this loop? HD or HGCB, and let's name this as P. So I'm choosing this loop HGCBPH. I'm choosing this loop. H2G, G2C, P. Write this, draw this circuit and try to write the equation of this loop HGCBPH and get the value of I from it. Your I will come in terms of E. Every resistance is 1 ohm. Do it now. Do it now. You just have one variable, you need one equation. Take this loop HGCBA and somewhere in your notes, write that while calculating R equivalent, we will always take the loop having the cell. If you don't take this loop having the cell, then your problem will not get solved. Because to solve this problem, you need the ratio of E and I. So equation should have E. Note it down and highlight this statement that your loop should always have the cell. See, these are all examples of NCRT.
Certain.
Okay. So write your answer in chat room. What value of I are you getting? What value of I are you getting? Okay. Try to get R equivalent, Ahmed. You have everything to calculate R equivalent. Like the answer that you are reporting, you have everything to get the value of R equivalent.
Okay, sir.
And if you look at carefully, you have got R equivalent. Mariam, make this equation and write the value of I.
Yes, sir.
What value of I are you getting? Your I will have E. Don't worry about E. Your I will have E because E is unknown. Get the value of I. Abdullah. No. No. No, Abdullah. You're wrong. Shazada. Complete your calculations and write the value of I that you are getting. Your I will be in terms of E. Except Ahmed. No, Ahmed. No. No. Yes, Abdullah. Write the value of I, yaar. I in terms of E. Okay. It's E. I'm asking of no, Abdullah, no. I don't know, yaar, what you're doing. I don't know what you're doing. See.
See, let's start from H to G. Current is I by 3, resistance is 1 ohm. You will write this as minus of 1 into I by 3 because you are moving in the direction of current. Then G to C, you're again moving in the direction of current. Current is I by 6, resistance is 1 ohm. So we'll write this as 1 into I by 6 now. Then going from C to B, it's minus 1 into I by 3. Okay. Then we move from here to here, and then we travel from lower to higher terminal. That's plus E is equal to 0. That is equal to 0. I by 3, I by 3, and I by 6. So it's minus 2I by 3. It's minus I by 6 plus E is equal to 0. So you will write that your E is, it's 2I by 3 plus I by 6 now. So we'll get E is, you can take this 6 as LCM, that's 4I plus I. So that is 5I by 6 now. Ahmed was getting this answer, 5I by 6. So you know that your I is 6E by 5. Is it clear, everyone?
Yes, sir.
Once you got I, then you can calculate R equivalent. Yes, a one-line calculation. How much is R
R
equivalent?
equivalent
R
was
equivalent is
E by
total
R.
EMF by
I, right.
total current.
Yeah.
So it's E by 6E by 5. This E will cancel. This E5 will go to the numerator. So your R equivalent comes out to be 5 by 6. So that's it. Okay?
So I messed up with this thing.
Must have been. Abdullah, clear?
Yes, sir. I just took that resistance as R. That's why I was getting.
Okay, okay. Mariam, Fatma, Shazada.
Yes.
See, it's an important, it's not a lengthy question. It seems lengthy, but it's a tricky thing. Like if you look at this circuit for the first time, you won't solve this in exam, you will quit it. But it's a very easy circuit. It's a 1, 2, 3 steps calculation, that's it. And it's an important question because it's given in NCERT, it's a short example of NCERT. Is it clear?
So R equivalent is 1 by 6R.
No, R equivalent is 5 by 6, that's it. There's no
Yes,
R.
yes.
There's no R.
Yes, yes, sir.
Okay, just note it down. Then we'll start meter bridge.
Yes, sir. Done.
Okay, this one more thing. Why are you not people attending those futuristic courses? Is there any issue with the timings? See,
No, sir. I thought they were not for us, so I did not.
no. That's for all students of Learnivio. We are currently running 3 or 4 courses that may be of interest for you. One is for robotics, another is for machine learning and artificial intelligence. We are teaching Python in those classes. Another is I'm taking, which is on astrophysics. Basically, not exactly astrophysics. I have started cosmology, like Big Bang, the birth of the universe, and all those things. And there is another course in biological science, like current research trends in biological sciences. The guy taking that biological science course is an active research. Like Rahul is still in TIFR, Tata Institute of Fundamental Research. So TIFR is one of the best research institutes in India.
Sir, we didn't receive the meeting ID for the bio.
Okay, I'll ask Nishkash to share that meeting ID. That course is on, I guess,
So I got for robotics and the other one, like
okay.
Python one.
I'll ask Nishkash to share all,
Yes,
astrophysics, cosmology, everything. You can join any course. Like as per Indian timings, that's 9 p.m. So for you, it will be around 6:30.
Yes, sir.
6:30, no?
See,
Second,
the purpose of education is not just passing school exams. Like, we don't really study physics, chemistry, and maths just to score well in exams. That's not just the purpose. The purpose is the training of your brain. And sometimes when you look at the application of the maths, the physics, the chemistry, the biology thing that you are doing in real life, then you will get motivated. Then your brain start taking it as something else than just a paper of 70 marks. Usually student take subjects just as a paper of 70 marks, that okay, by doing these questions, by just memorizing these derivations and these formula, you can score some really good marks. Honestly, those marks are not that important. The thing more important is the training of your brain. Einstein used to said that education is not the learning of facts, it's the training of your brain to think. And the motive of those futuristic courses is that only. We just try to push you to a limit that your brain starts thinking about those things. Kirchoff law. After Kirchoff law, the next is some application of Wheatstone Bridge. Say Wheatstone Bridge is a theoretical model. We don't make Wheatstone Bridge in laboratory. It's a theoretical model. That's it. Like this 2 plus 3 equal to 5 is theoretical. If you want to make this in laboratory, then what you will do? You can take 2 pens, you can take 3 pens, and then you combine them up and you say, okay, it's 5 now. In the same way, Wheatstone Bridge is a theoretical model. But when you make a practical application of Wheatstone Bridge, that is known as meter bridge. This is what we make in laboratories. Meter bridge, practical application of Wheatstone Bridge. Continuous revision, Ahmed. Revision not always means that you open a book and you start revising things. You can revise things even when you are traveling.
so
Just
for me
put
it
those
is like I understand stuff, but during exam everything is blank.
because you understand everything, then you let your brain forget everything. So the best thing is just try to revise it as frequent as you can. Revision does not always mean that you open the notebook and then you start revising. You can revise while you are walking. You can revise at when just 10 to 15 minutes before you sleep. Just try to train your subconscious mind to revise whatever you have done. Continuous revision is very, very important.
Okay, sir.
When I was preparing for my PhD entrance exams, what I used to do is I used to make MP like some audio recordings of the important concepts and the formula, and I keep on listening those recordings while I'm traveling in a bus or I'm driving. So that thing helps a lot. Then I start. Then a phase came and I don't need those audio recordings. My brain was very much trained. Then I used to revise it without that audio devices also. Like I think of some topic, like I think of electrodynamics, and I try to recall everything that I have done in electrodynamics. That thing is very, very helpful. Practical application of Wheatstone Bridge. That's meter bridge. When you make in lab, you don't make Wheatstone Bridge in lab, you make meter bridge in lab. So this is how we make meter bridge in lab. So that's your Wheatstone Bridge. Also, Mariam, you want to prepare for NEET as well, right?
Yes, sir.
So if you want, now I can shift you to batch NEET target batches. But do you understand Hindi, Urdu?
Yes, sir.
Okay, then it's fine because the medium of instruction is English. Like we use both the languages. 3 off. So if you want, I can transfer you to the batch having NEET targeted batches. Let me talk to the teachers. Because now you have vacations, you can utilize those vacations. And you can join all those batches along with these batches, like this batch.
Okay, sir.
Also, Mariam, was one last thing. We are also conducting a crash course for the students who are preparing for NEET. Like in NEET, maybe is in August or in September. So we're doing a crash course of some 200 hours crash course. You can join that crash course if you want. You can at least revise your class 11 stuffs. And those, you don't have to pay anything for that crash course. That's free for our students. So the 240 hours crash course, various faculties are teaching different subjects, like different topics. Someone is taking thermal, someone is taking mechanics, someone is taking SHM and waves. In the same way, in chemistry, someone is taking organic, someone is inorganic, someone is teaching physical. Similarly, we are divided biology into many parts. So if you want, you can have a very quick revision of your class 11 concept.
So is it just for NEET?
It's for NEET as well as JEE.
Okay, sir.
But the syllabus of NEET and JEE match with that of your NCERT syllabus, right?
Yes, sir.
So if
So
you
is
want
it like they'll be teaching both for both in the same class?
both in the same class, because
Okay,
there's
sir.
a differences in mathematics only. So if you are in JEE, so you will be attending classes of maths, and NEET people will be attending that of biology.
Okay, sir.
Okay, so that is your Wheatstone Bridge. This is your Wheatstone Bridge. When we make this Wheatstone Bridge in laboratory, what we get is meter bridge. So while making meter bridge, what we do is, instead of these wires, we use thick copper strips. Like we use copper strips in this way. This is one copper strip. There is another copper strip. There is another copper strip. We use thick copper strips instead of wires. This is another copper strip. Abdullah, why we use thick copper strips? Why don't we use thin strips?
So because the flow of current is more easy and thick.
Nah. Think in terms of resistance. You know how resistance varies with
Yes,
area.
yeah, because in thick the area of cross section is more, so resistance will be less.
That's the reason. Because for thick wire, area of cross section is more and resistance is less. So this is point A, this is point B, this is point B, and this is point C. See, I'm taking both as points B because they are identical. Let me write their name. This is A, this is B, this is C, and this is D. So this is point A. Instead of wires, I'm using thick copper strips. This is your B point. So I connected a resistance. You can call this as R1 here. Then between B and C, you have another resistance, which is R2 here. This is your point C. No, this is A, and this is your point C. See, the points which are on a conductor are identical. If this is A, this is also A, this is also A, this is also A. And then in between A and C, you have cells. So we connect a cell in between A and C. So there's one more thing. This is this wire AC. The length of this wire is 1 meter. That's why we call this as meter bridge. Meter bridge means bridge having 1 meter length. That's it. That's why we call this as meter bridge. So next, what we can do is we can connect this with the galvanometer, and we can put galvanometer here. So this is your point B, and this is your point D now. The resistance to the left is R3. The resistance to the right is R4. We will see how we decide what is point D now. This is the meter bridge now. Instead of wires, you are using thick copper strips. You're taking a wire AC, 1 meter long wire. A portion of this 1 meter long wire will behave as R3. Another portion will behave as R4. And there is one galvanometer in between B and D now. This is it. Okay, just note it down. Abdullah, have you decided what you will do after class 12? You're staying in Bahrain only or going back to Pakistan? Abdullah, you're in class? No. Abdullah have left. Okay, you'll go some other country. You should prepare for SAT then, Abdullah.
Yes, sir, that's my aim. Prepare for SAT.
For SAT, for getting admission in Europe along with SAT, you will need some project work also. You should take those courses like courses on ML if you are interested in coding, or course on astrophysics if you're interested in astrophysics.
It's a basically coding only, like.
If you're going, then join that class. We can do some live projects also. Those projects will help you in admission procedure.
Where?
That will help you in scoring some extra marks.
Yes, sir, like where are those classes? Like I never got them. You will send the link?
Yes, sorry.
You will send the link of those classes?
Yeah, Nishkash will send the link.
Okay.
So, where exactly, Mariam? Where exactly? That matter. Where you want to go for your MBBS? Yeah, Canada is a good option, but you should at least try for NEET. Like if you can get admission in India, then medical colleges in India are really good. Some colleges are really good.